Hello, this is Professor Scott Norman at Pittsburgh State University. Today we are in the Automotive Technology Lab, and this is part 2 of how to find a restriction in your AC system. So on part 1, we showed you a restriction that was a low side restriction in the TXV. So it was between the high side and the low side service port of the system. So that's an easier restriction to find. I mentioned on the first video that depending upon where your service ports are and depending upon where the restriction is, it's sometimes a little bit harder. So I wanted to give you a second scenario as far as maybe a high side restriction in which the restriction was before the high side service port. So when you think of an AC system, think of the compressor as the beginning of the refrigerant cycle and then also the end of the refrigerant cycle. And so we're going to show you a restriction in the system. On the high side, think of maybe a condenser restricted or a receiver dryer restricted. And the service port on the high side of the system would be on the liquid line, so it's after the restriction, and show you how the results are. So right now we have the AC gauges hooked up, and you can kind of take a look at it. The system has not been started yet, and so we have a static pressure system. The gauges are equalized. They're reading the same, ambient temperature is what I would expect. It's about 75 degrees here in the shop today. And so we'll start the system up, we'll turn the AC on, and we'll take a look at what the gauge readings will show. The vehicle has been started, and if you take a look at the gauge readings, you can tell that the AC is on. So we will let the vehicle run for a while and come back when the vehicle is fully warmed up, so you can take a look at the final gauge readings. The vehicle has been running now for quite a long time. It's not blowing cold air. The AC lines, when you feel them, nothing is hot, nothing is warm. The suction line feels a little cool, maybe a little cold, but definitely not normal temperature range. When you take a look at the pressure readings, the high side pressure, looking at 65, 70 psi. The low side gauge reading is around 35 psi. So I think most technicians, when they would see this, would think it was an undercharged system, and they would recover to see if it was low charge. And if you take a look at this, it is a normal charge system, so the vehicle is not fully charged. Since the restriction is before the high side service port, the high side and the low side service port, they are reading similar. They're both reading probably very similar, and obviously the high side is definitely very low. If you tried to do your normal test, your equalization test, if you tried to recover on just one port, the results are going to be inconclusive. It's not going to find the restriction because the restriction is before the high side service port. So the high side and low side service port is connected together. They're able to be, you got a pressure drop through the normal TXV system. So again, this is much harder to find. If the high side service port was on the discharge line before the restriction, we would expect to see higher pressures than normal because of this particular problem. Let's turn off the vehicle now, and let's see what happens with our equalization time. So if you take a look at the gauge readings, the system equalized pretty quick. They're both reading around 40 psi, which is low for a 40 warmed up vehicle. and the the restriction is before the high side service ports. Again, these tests are inconclusive. They're reading the same. So again, it's a little bit harder to understand what's going on. The best way to find a restriction like this is if you had a pressure transducer on the discharge line, because if I have a pressure transducer on the discharge line, I can take a look at the pressure on the scan tool versus what the high side gauge reading is, and at that point you're able to determine if there is a restriction either in the condenser or in the receiver dryer. You take a look at the scan tool pressure. The high side pressure on this system is around 99 psi, right around 100 psi from the pressure transducer on the scan tool. So you can see that right here. It says 101 psi right there, to make sure we can see that. And my engine temperature is around 194, so you can see that the engine is fully warmed up. But when my AC is on, if you take a look at the high side and the low side gauges, the high side and the low side gauges are reading around 30 psi. They're reading about the same, which is indicating that they're the same side of the system where the restriction is in front of the high side gauge. And so, if you take a look at that as far as the actual pressure drop through the condenser and receiver dryer, going from 101 psi down to around 30 psi, that's a pretty good, I'm going to call partial restriction through the condenser, through the receiver dryer. We did remove all the refrigerant from the vehicle to confirm the charge, and it was charged up properly. So we charged it up with the correct amount of refrigerant, and again, and so these are our current results on that. So the key is that when you're looking at restrictions in the system, high side restrictions are not what they seem. You would think with a partially restricted receiver dryer condenser that the high side pressure would be very, very high. Well, in this particular condition, it is not. We're seeing around 105 psi on the high side service port, and that's all we have. But we do see a giant pressure drop between the discharge port and the liquid line here, and so which is an indication of a restriction in the system. This is Scott Norman, and if you're looking for more automotive educational videos, you can visit my Professor Pintane YouTube channel. I'm on Facebook, and I also have a webpage. Just look for ProfessorPintane.com. Thank you very much. You guys have a good day.